think we should start. Is everybody here? We got 5, 8, 9, 10, 11. I'm missing 2. Okay. We'll start anyway, I guess. It's already 2 past. Sure this is working. Yep, looks good. Good morning. How's everybody doing? Nice. Don't all speak at once. How are we doing energy-wise? It's past hump day on week 2, which is not an easy week. I see nods, so people are not exhausted, which is nice. How was yesterday? I saw in Compass for your cohort, I was pleasantly surprised this morning. I saw when I checked in terms of completions, everybody seems to have done, at least according to what Compass is showing, done with yesterday's content. How long are people here until? 9? Were you catching up from the previous day and then doing that day, or was it just like you're pretty much caught up every day? Pretty much caught up every day? That's pretty cool. Yeah, we made some tweaks to TinyApp a couple of cohorts ago to kind of smooth out that process a little bit. But there's like needless friction, and then there's like intentional friction, right? So there's still going to be intentional friction, because we are here to learn problem solving, aren't we? Right? So I should probably introduce myself a little bit. It's my first lecture with y'all, which kind of sucks because I had 2 others scheduled with you that Nima had to fill in. I was not feeling too well. I threw my back out. I'm still a little bit tweaked, so I might end up using the stool. I'm not really sure how it goes for standing for 2 hours. We'll see. So a little bit about myself. My name is Karam Virani, as I introduced myself on day 1. People just call me KV here. It's much easier. It's totally okay, whatever we want to call me. Karam is fine. Some people mistakenly call me Kareem. That's totally okay too. I don't really care, as long as I understand that you're talking to me, right? I like to start off with a joke, so I'll do that, and then I'll talk a little bit more about myself. Jokes I try to keep them relevant, like nerdy enough and relevant enough, but I don't have an HTTP one. I should. Probably there are quite a few HTTP jokes. So I'll just do my software development joke, which is hopefully not used yet. How many software engineers does it take to screw on a light bulb? None. It's a hardware problem. We like to blame the hardware people whenever something goes wrong, right? So a little bit about myself. My background is in computer science. I went to University of Guelph, graduated I think 2005. And essentially have been in the workforce, even during university actually. I was doing some dev roles there. Started off with Java and .NET, but quickly realized that I wanted to get more into the modern open source stack and work with startups. And this was all in Toronto. And so decided to work for a startup, kind of took a pay cut, went from like a lead dev management role in .NET, in a .NET company to like a junior Rails developer, we were called at the time, because it was very like stack specific, right? Those were, I guess these days also, sometimes people call themselves a React developer, so there is still some like stack specific, like framework specific naming of our roles, but less common these days. So anyway, junior Rails developer, worked for a startup called MDialog, video-based startup, pivoted like 5 times, it was exhausting, crazy hours. Learned a lot and really enjoyed the CTO and like the team, and eventually though left. I felt like I was kind of hitting my ceiling, and I think a year and a half in, I decided to leave. A couple of years later, they got acquired by Google. So maybe I should have stuck around and taken that equity that was being offered, but I didn't believe in them in that time. After 5 pivots, I was like, I'm done. I might be exaggerating the 5, might have been 4, but either way, it was a lot. But I've always had a passion for software development. I think when I started working with computers, that was in Pakistan where I grew up. I think I was around 8. And around between 8 and 10, I started like actually teaching people how to use computers, volunteer position sort of thing. Always kind of didn't realize it, but I was starting to build my passion for teaching. High school, university, same thing. I was TAing a lot. Since the MDialog thing, jumping forward again, worked for various different startups after that. Consulted a little bit as well, kind of working from home or co-working spaces, and then eventually started up a consulting company doing software development for hire, essentially, and built up a team to about 10 people. And a few of them actually were bootcamp grads. Either the bootcamp that I worked with prior to starting Lighthouse, Bitmaker Labs, or Lighthouse Labs grads as well. It's pretty cool. And learned a lot from and not just from that, but even from previous, learned a lot about what makes a really good junior dev? What makes a good career progression for junior dev? So I put a lot of thought into that, and it obviously fed into Lighthouse Labs quite a bit as well. My lecture style is fairly similar, I think, to Nima's. He uses the editor a lot, right? Not a lot of slides. Is that right? You haven't had Carl yet, I don't think. Carl's a bit different. He's the most polished slides I've ever seen. Incredible. I sometimes steal them. Nima does too. So very focused on design and user experience. And he's probably one of our strongest, in terms of our instructor mentor pool, he's one of the strongest React devs, I believe, in Vancouver. So he definitely is more, you'll see him a lot more on the React weeks, for example, where he's doing a lot of his focus these days. And I think you've just had Nima and Travis, is that right? Sorry? Andy? Okay, nice, cool. Yeah, in terms of my style, what I'll say is I like to take awkward pauses. Right? I have my glass of whatever it is or cup of whatever it is to kind of let you interject with questions. One of my pet peeves from university was instructors wouldn't pause enough for questions. And when they did, they would say oh, do you have any questions? And then they would literally wait for a second. You don't really have that much time to think about what you're going to ask. So what I kind of want to encourage from everybody here is it's okay to interrupt with a question. You can yell it out. We don't have a satellite cohort for this cohort, so it's easier. You can also raise your hand if you want, just whatever works for you. And if one person is, or if the question's too advanced, I'll let you know that, hey, we're going to cover it later or whatever, right? You can rely on me and don't get offended if I kind of curb the question a little bit. My philosophy on lectures is that they don't work well. Maybe it's just me, but I find that people generally, my attention span is 10 minutes. I zone out after a 10-minute, while having a 10-minute conversation with someone. So I will not judge you if I say hey, what do you think? What's your name? Steve. Steve, what do you think about what I just said? And Steve's I was not thinking about what you just said. I was zoned out. Totally okay. Just mentioning it out in the open so we're all comfortable with responding in that way and nobody's being judged here. It's mostly my responsibility to keep you engaged, but I also don't expect to perform 100% on that, just because of the nature of lectures. So let's just put that out there. But I will do my best. I tend to get excited in terms of a fault. I tend to get excited and talk fast. So feel free to use questions or other tactics and just say, hey, could you repeat that or whatever, slow down to get me to reset. It's just a personality thing, right? I try to watch it during lectures, but I can see myself doing it right now, for example. So please let me know. What else? I think that's everything I wanted to talk about in terms of kicking things off. We have a lot to talk about this lecture, actually. So just setting expectations. Today is there's a lot of different topics. It's all under HTTP and user authentication or cookies, really. But my approach to this lecture is a little bit longer than other instructors because I don't just talk about what are cookies and go right into it. I actually, so this is another point I want to make about my lecture style. I will try my level best to make the lecture not about knowledge transfer, because they suck at that, and more about critical thinking and problem solving together. So we will try to invent solutions that may not even be good solutions, as we'll do in this lecture, so that we are engaged and thinking about how we would do this if, for example, cookies didn't exist. How would we handle the problem that stands before us, right? So we'll do that actually in this lecture. And I don't know anybody's names. I mean, I know a few people's names, like Carlo. I think I know your name, right? Carlo, right? Aside from that, I don't know anybody else's name, I don't think. So I might write them down here, and I'll ask you for your name as we progress. You're Steve, you said, right? Yeah, sweet. So this is the agenda. We're going to do a little bit of recap of HTTP. Then we're going to talk about one of the problems of HTTP, which is statelessness. I'm assuming you've come across it in your readings multiple times, but I find people are often confused about it nonetheless, and so we'll do a quick recap on that. And then, because it's also relevant to us, and then we'll talk about before we talk about how cookies solve that, we'll actually talk about how to solve it without cookies. Again, I'll actually ask you to solve it without cookies. And then we'll talk about, yeah, there's a lot of problems with that approach, and then we'll list those problems out, and then see how cookies solve those problems and which of those actually get solved. The reason I do this is I find that having done this lecture multiple times, previously I used to do kind of like the traditional approach, how it's usually taught online and videos and stuff like that, where it's just like, here's cookies, here's the problem that they solve. And oftentimes people actually conflate the problem that cookies solve. They don't actually understand what's the actual value proposition there. So hopefully by doing this approach, you'll feel a little bit more comfortable with that. By the way, there's a whole bunch of stuff encompassed usually around each lecture, like bullets or paragraphs. I don't always just follow those. I don't think any instructor really does, so just keep that in mind as well. My focus isn't about covering all of the bullets or learning outcomes for a lecture. It's really about, again, the critical thinking and engagement aspect. Because I know that lectures supplement the material, there's nothing in lectures usually that isn't already in your exercises. So if I miss a particular thing, for example, at the end of this, I want to talk about security implications. I've marked it as stretch because this lecture is long, and I don't know how long we'll spend on the other stuff. If I don't get to it, I don't feel terrible. It's going to be in my notes, right? And regardless of if it's in my notes, you'll cover it at some point. So I'm not worried about that, right? We'll also, of course, be looking at code a bit. So we'll do 2 demos. We'll do a language switcher demo, where websites have like the language switcher on the top. We'll just do English and French, and we'll implement that using cookies. And we'll see what that looks like. And then we'll do another one for user authentication. Again, it won't be like the code that, it won't be extensive code. We won't be spending a lot of time cleaning up the code. So please don't consider it like this is KV's quality code. It's not, right? Like it's lecture quality code. So there's a lot of refactoring that would be needed. For example, the stuff you'll implement in TinyApp will hopefully be better quality, right? Are you guys enjoying TinyApp so far? Yeah? You got the double entendre there with TinyApp. It's a small app, and it does tiny URLs. Did anybody catch that? No? You don't find it tiny right now. That's why you didn't catch it. You're like, this is huge, guys. 2 pages. 3 pages, I think, right? Yeah. Okay, so let's go back to the beginning and talk about HTTP and recap that a little bit. So first thing I want to kind of recap because it's going to be important to like a building block for what we're doing. HTTP is all about requests and responses, correct? It's very transactional. And requests specifically have 2 important parts without which a request is not really complete. There's a lot of other stuff that can be passed in through headers, but what are the 2 required things in every HTTP request? The verb, yes, which is also referred to often as the method. So examples of that is get and post are the most common. The body is the most important, one of the most required ones for responses, I believe, but not initially requests. The path, yes. What do you actually want, right? What do you want, and how do you want it, right? Makes sense for a request. So the path would be something like, could be a relative path, so would be something like slash or slash FAQ or whatever, right? Everything else is optional. For example, one of the other things that's often in sometimes the path itself is like, have you guys seen this in websites, the question mark? And then you'll have like on Google, for example, Q equals some search query, right? So these are optional kind of, they're called query parameters or query string parameters or URL parameters. They're parameters being passed in through the path or through the URL, right? I don't think TinyApp has any of this, which I don't like, but that's the case right now. So that's a good recap. If we're comfortable with this, yes? And then the other thing I want to talk about before we really get into solving the problems, and the main problem we're going to try and solve is this spelled correctly? Statelessness? Maybe like that? No, that's definitely not. Okay. That doesn't look right, but okay. Is it like this? No. Okay. My English not so good. Statelessness. Somebody tell me what it means for HTTP to be stateless. I want a concise answer. So try to be technical, but try to not be too technical. Sorry, you want to take a... What's your name? Govind? Yep. That nailed it, actually. Usually not the case on the first answer, but I appreciate that. I was hoping for a wrong answer first, man. I guess Nima's been doing a good job during lecture, eh? HTTP tends to forget who each client is between requests. The way I like to describe it, I don't know if Nima has already done it this way. The server has amnesia, is what I like to say. I can relate to it because I have trouble remembering people's names or whatever it may be, right? And sometimes I feel like a HTTP server, where I have information about you. Like, so this is the thing that people often get wrong about statelessness. They say something like, HTTP servers can't store state. Well, it's like the HTTP as a protocol maybe has a state issue, but the server itself, I mean, it has information. State means data, right? State means information. And software is really about two things, isn't it? Data and behavior, as far as I'm concerned. There's functions, and then there's data. It's how we operate on the data. And so state being the data, often people conflate statelessness to mean that the server doesn't store state, but it does store state, right? It includes information about yourself. It has a database. All right, but what it doesn't know is when a request comes in is who that person is, who to look up in the database. Agreed? Oh, yeah, maybe the word tens isn't good. Maybe making it too anthropomorphic. Maybe I just mean HTTP doesn't care who each client is between requests. And even that's kind of too, doesn't remember. So like, the analogy I like to use is, you go to a convenience store that you've gone to like your entire life. Have you guys seen the show Kim's Convenience on Netflix? Highly recommended after boot camp. Shot in Toronto, I think Sherburne and Adelaide, for those of you. Anybody here from Toronto? No, I am, so. No. But anyway, I was like, oh, I know that hood. I used to work around there. And it's a very PG show. It was actually a play that got turned into a TV show by some Canadian some Canadian publisher. Anyway, so you walk into Kim's Convenience, and every time, Kim doesn't seem to know who you are, even though you've gone there your entire life. And so what you have to do, you have to kind of identify yourself a little bit. And then Kim remembers who you are. Another analogy that's maybe more relatable is going to the gym, or like a YMCA type of situation, where yes, the YMCA has your membership information on the front desk, at the front desk on a computer, but what do they give you? They give you like a little thing to like identify yourself, right? Maybe that thing actually brings up a picture of you so they can make sure that you're the right person and stuff like that before they let you in for your gym membership, right? So that's an example of, you could be coming in and out of the gym, but every time you come out, you need to get access back in, and so you need to identify that piece of information, right? We'll use that analogy a little bit going forward as well. Does that make sense to everybody? Is that okay so far? Any questions about any of this stuff? It's a good review, but let's move on. Okay. Let me know if you have any questions and we'll tackle them. So normally at this point people go, and cookies solve this problem. We're not going to do that. Right? We're going to get there, but I actually want to solve the problem without cookies, which is not in your content. I don't think. So this is to you. Well, let's actually write the problem a little bit more. This is the problem. Let's actually use user authentication, even though that's not the only thing that we're going to use cookies for. As we'll see, we'll use it for language switcher. User navigates to some kind of page that requires them to be able to log in, to be able to see their profile, right? So they do a get to /profile. Server realizes they don't know who this is, right? Server does what at this point? It just says, I need you to log in, right? Correct? So it sends a redirect to client for /login. Client, being a good browser that behaves well and listens to the 302 with the location specified, goes to that location with another GET request. Right? Server renders the login page. User fills out their creds. Let's call them valid creds for a happy path, kind of a good scenario. Yes? And then Then what? User clicks submit or whatever, hits enter. Server will do what at this point? Validate that the credentials are correct in the database, right? Are you able to see this in the back? Especially you right there? Okay, back. Okay, great. Zoom in more if you don't. And finds the user object successfully because it was valid credentials, so it's not like undefined or something. It found the user object. And then what should it do? I mean, this is the case where it's not working, right? So the server would say, okay, now you can go see the profile page. You're logged in. So server redirects to slash profile, where they were trying to get to. User browser makes get profile again, right? However, server has no idea who the user is because they have amnesia, right? So we repeat from which point on? 3. So we're caught in this loop, right? Because of the statelessness issue of HTTP. So this is what we're going to try and solve without cookies. We know cookies will solve this for us, and we've done a bit of reading on that, and we'll do that as an exercise. But before that, how do we actually remember who the user is? That's what we really need to solve, is that point between 7 and 8. I think it's between 7 and 8, right? Where, again, don't think about the viability or feasibility of the solution. It's not a good solution, but what could we do so that that doesn't happen? We have one hand up, but I want other people to think before we jump into the answer. It's a common mistake that I find instructors making, including myself sometimes, where we just jump to the first answer. So one answer, other people? I want to see more hands go up. Stephen, right? And your name? Sorry, in the back. Bobby? Bobby and Stephen have their hands up. Anybody else? Going once? These were the confident hands up, so I want to see like less confident answers first. Steve, right? Yeah. Yeah.
All right. Would you create a for a specific URL, like we did with call it to the IP parameter?
You're on a very good right path. Yes.
Yeah.
So elaborate a little bit more for everybody here.
So basically, what we did with the Tiny app, when we created a new app, assign a number to it, go to that profile that would be custom to that person, and then pull it up.
Yeah, you're on the right path. Your answer is technically correct, but there's a slightly different way of doing what you just said. Essentially, you said modify the URL, which is on the right path. Is that a good hint for those who didn't have their hands up? Anybody else want to take a stab before I ask Bobby or Steve in here? Yeah, in the back. What's your name? Create, which is very similar to what you're saying, right? /kv/profile, right? That kind of thing. Exact same answer. Some very, very close to what I was thinking in my head, so it's technically correct. Yeah. Yeah, I was hoping somebody would say that IP address usually comes up as a thing to uniquely identify. So maybe on the server you could store like for this IP address, it's KV that's logged in, and so anytime I get a request for that IP address, I know that they're logged in. I don't need a URL change, which has its problems that we'll see, right? The problem is the IP address doesn't work. Does anybody want to chime into why IP address doesn't work? Aside from Steven, yep. Seth? Multiple users per IP address is the most concise way to answer that. Why are there multiple users per IP address? IP address is supposed to be how we uniquely connect to a machine. How can there be multiple one IP address for hundreds of machines? That doesn't make any sense, right? Like, I should be able to connect to an IP address, port whatever. We're told that's how we uniquely identify a particular destination. And yet you're saying there's multiple computers that are sharing that IP. What gives? This is getting into kind of networking and a little bit of a digression, but we'll talk about it a little bit. Yep, Steven. Yes, it's the IP address behind which a whole bunch of computers are sitting with their own unique IP addresses that are local. So we all have a local IP address. If you option click on a Mac on your Wi-Fi in the toolbar, maybe I'll show you. You'll see here that my local IP address, which is unique to this local area network, is this. But my public IP address is not even shown here. I don't think. Yeah, it's not. I would have to like go to a server to check my IP address or something like that, right? Or I'd have to look at the network settings. Yep. Yeah, so that was another good answer, or an answer that I was hoping somebody would say. So IP address, we know that doesn't work. We agree before we move on? The other thing I want to say about IP addresses is not just like, for example, our office will all have the same public IP address, but if we're using, I believe if we're using a like 4G, 3G, whatever, cell tower, I believe people connected to that cell tower will likely have very similar IP addresses. So even while we're roaming, we have shared IP addresses because we're behind a cell tower, which is its own router, essentially, right? I haven't tested this, but I believe that to be true. So that my mental model is hopefully correct on that. And then MAC addresses, which are absolutely unique, universal kind of hardware address for our networking card that is globally unique, is not shared actually due to privacy reasons. Because as soon as we share that with a web server, what happens? From a security privacy standpoint. Yeah, they can kind of fingerprint you, right? To the point where, yeah, hacking would be a lot harder. But more importantly, it would be very easy for any service to fingerprint you, not just fingerprint you for their domain, but fingerprint you like across like your entire behavior, like anywhere you go on the interwebs, right? So browsers are actively trying to prevent this because there's hacky ways of fingerprinting people. You might have come across some articles recently about Firefox doing a big push. Did anybody come across Mozilla doing a big push to try to get you to get off Chrome? Or more specifically, to stop websites from fingerprinting you. If you're not sure what fingerprinting is, I forgot to mention this in my preamble. Write down things that are digressions in my lecture because we won't be able to go through all of those things if you're curious about researching them after. Right? That's another value proposition of lectures, is these conversations that aren't necessarily intentional, but we can't go spend a half hour talking about them. So that's where I expect you to take notes. I don't expect you to quote along, of course. So yeah, we can't use MAC address, we can't use IP. We were on the right path with URL. Does anybody want to elaborate? The problem with the URL approach that Steve and Bobby, in the back, Juan mentioned, is that you've just kind of solved the problem for profile. But like, imagine any part of the website that needs to have a person logged in. I don't want to have to support /kv/tweets/kv/everything just for all my secret pages. There's a better way to modify the URL. Yep. Yeah, exactly. Exactly. Yeah, so it's still in the URL, so nothing really has changed, but just slightly in the structure. Because I kind of hinted at it earlier with this, where we can pass in /FAQ or /me, let's say, right? My dashboard, user equals KV. Maybe I want to be really clever for security reasons and just say like you so that the user doesn't know what that is, right? Talk about like security to the max, right? Right, so essentially still modify the URL, but instead of doing /kv/my dashboard, I've kind of done it this way so that any URL could really have that optional thing attached, because I could either be logged in or not logged in, so it's optional, right? That parameter. It's not required. I mean, technically it's required for that page, but it's optional across kind of the website, right? Am I talking too fast? Is this okay in terms of my explanation so far? Any questions? The question mark delimits, it's a good question. What does the question mark mean? The question mark delimits the path. So I want to say this is the path, question mark, query string params. Okay. This is how we make an HTTP request, essentially, for a GET specifically. Well, it doesn't have to be for a GET, but like, you know. And this part here, we agreed that these are the two most important parts. We wrote them right above. So those are required. But then we can attach this params thing. Now, what does it look like? It looks like this. And it could have other things like ampersand lang equals English, right? Ampersand theme equals dark. You know, things like that, right? So we could have a near limitless, quote unquote, list of key value parameters, much like they would be in an object key value, but in the URL. And so we're gonna do this. So that's what we're gonna do. Yes, you have to kind of separate. Good question. So I didn't explain that properly. The question mark is just separating the left from the right. Yeah. So with that said, how would we actually do this? We'd modify this by saying, kind of cross that out, and server redirects to profile question mark u equals kv. Let's assume that's my username. At which point the browser has to follow that particular path. At which point, based on the u param, right? Server finds valid user object and is happy. Server renders the /profile EJS or whatever it is, right? Right? Now, what are the problems with this approach? There's multiple. And this is, again, back at you. And don't all, in this particular case, I want you to think about it a little bit. So raise your hands instead of blurting it out. Okay. And hands up there. 2, 3, 4. 5. I haven't spoken to you yet, so why don't you go first? Yeah, so it's very easy for the user to brute force guess usernames and impersonate someone else. Is that what we're saying? In different words? Brute force is just a common term for just no real intelligence, just like keep guessing. I don't have any insight. I'm just going to keep trying different combinations. Maybe even make that program, right? Like a bash script that like loops through a bunch of letters and just like does a curl command each time and sees what comes back. Or it could be a Node app itself that does the brute force attack. Or you just try it manually in a browser, right? So that's a security problem. Agreed? There's also usability problems. So that's probably the major security problem with this. It's very easy to guess. What are the usability problems? Yeah.
If you're like making like a video or something, right? You want to make a video.
Yeah, exactly. So sharing URLs means sharing your logged in state. Right? Like in case it was because if I'm going to be logged in on every single page, now my query string u equals kv is not just going to be up for my profile page. Everywhere I go from there on, even a public page needs to know that I'm logged in so I can, I don't know, vote for things, whatever that may be. It's going to have, you know, a public video URL, for example, with question mark u equals kv. And as soon as it reads that, it's going to log me in as that person for that particular request. And so that's not going to be cool if I'm sharing YouTube videos where people are, when they click on them, they log in as me. Right? So that's also a security issue, but it's also a usability problem. I can't share videos, right? I can't share URLs, I should say. Right? Steven? Yeah, it's a really good one. It's a hard one to think about a little bit because it's a little bit more of an annoyance than anything, but kind of makes the app hard to use, right? With how we use apps, we know that when we log in and we close the tab, we'll come back to that tab. It's all good. We're still logged in, right? In this case, closing the tab/window and coming back will mean I'm logged out. I mean, unless I go back to the URL with u equals kv in it, right? But still, that may not happen unless I'm like going through my history or whatever, using my history. But if I'm not, then that's a problem. Yep. Oh, so that's a good point. Someone else with KV in a collision between two different users, we're assuming that this is a unique ID. So you can't sign up with the same username if one exists. Yeah, so that's not really too much of a concern. Okay, Steve. Yeah, that's another annoyance from a developer standpoint. So this is a usability issue, number 3. And I'll repeat what Steven has said, which is another more of a dev issue, right? More of a dev issue that I have to now in my EJS say, if user is logged in, then the link will render the link to homepage to be home/home !u equals, and then inject the username there. And so you have these like if-else essentially in every single link on your website. Or maybe a more concise if statement, maybe a ternary or something fancy. But ultimately a conditional to either include the u or not include the u. And that's a bit annoying and messy, right? Shouldn't really ideally have to modify that. So that would be essentially, maybe it would be like this. Although you could probably get away without the conditional. It would be like that, and then question mark. Actually, probably just to keep it simple. My God, it's getting messy already. I'm just making up an object here. It doesn't actually exist, right? It's just pseudocode. But writing it as though it's EJS, right? So this is outputting the current username right after u equals to render that bit of HTML. Right. You could be more clever with this, but just to kind of elaborate the point. Oops, sorry, what am I doing here? I was writing Ruby for some reason. Right. Cool. So these are some problems that we're going to have to solve. I don't think is there anything else that I'm forgetting or any other problems that you want to mention? Easy to guess someone and try to log in as them. That's probably the biggest one, right? Can we agree that's the biggest one? And then of course this is tied in where you can accidentally guess someone's by getting a link, right? So that's another problem around security. And then, yeah, I think those are the major ones. So it seems like storing our important, secure information in the URL state doesn't make sense. Agreed? And this is the problem, actually, that cookies try to solve. Okay, so they don't enable anything that you can't already do. They just hide it from the URL. So instead of including u equals kv in the URL, we can instead store that in a cookie. And we can have multiple cookies, just like we can have ampersand in the URL. We can have ampersand in the cookies and actually have multiple cookies set for a given website. And what does the browser do with cookies? What have we already learned about cookies from yesterday, from last night? How do cookies work? And of course, we'll show that, but I'm guessing some of you already know. Yeah. Yeah. The cookie is assumed to be stored by the client. And assumed that the client will behave well. So this is a good browser, not a malicious browser or a confused browser that has amnesia itself. That would kind of suck, right? And actually does remember to send that cookie up with every request. So it's like it's in the URL, right? It's that key value. We wanted it in every URL after they log in. And guess what? The cookies do that. So it's actually perfect fit, except they don't include it in the URL. So what problem does that solve for us? It's not included in the URL. So I think it automatically solves number 2. Because that's the sharing problem where it's in the URL, right? So let's just bring these back. Let's revisit these earlier problems, right? Bring them back. So I know right off the bat, I believe, that this one's like solved. It's not, we don't have u equals kv in the URL. If I share that URL, it's fine. Agreed? What else? What about number 1? Yep. If it's on the browser, the question is, can you edit cookies on the client? You know, I kind of threw the hint out there as a well-behaved browser because ultimately curl can be used to make requests, and you'll see a request come back saying, or response come back saying, please set this cookie. And then it's up to our next curl command to decide if we want to set it or not, or what we want to set it to. Like if I look up, you know, curl, the manual for curl, cookie jar. Hey, by the way, what happened to the cookies? I was supposed to have one. Did everybody get one? There was one for everybody, right? So did everybody take one? You want to get one? Totally forgot. When I got the cookie jar, I was like, oh, I feel like a cookie. Not that I feel like a cookie. I feel like having a cookie. Right? That's the difference. Some days I just feel like a cookie. Have you had one yet? Yeah. Who hasn't had one yet? There's still 3 left. Okay, cool. Well, I'll leave them here on the bench. On the stool. Yeah, so yeah, you just pass in /-c and then you can pass key value pairs up. Even if they were never set, you can just be like, I'm going to guess u equals kv here. Yeah, it seems that way, doesn't it? You could try any value. Yeah. Awkward. So this is really not solved. We think, right? Like, we'll see that a little bit more. What about number 3? Solved? Because cookies are supposed to be saved in the browser, and we have seen this like clear your cookies thing that nobody uses anymore, right? That's supposed to clear all your cookies. By the way, did you know Google released a update about a year ago on cookies? You know, the clear cookies function? It removes all the cookies except for Google's. It's a convenience thing, guys. You know, that way you can stay logged in the browser. So it's a convenience thing. Right. Thanks, Google. Yeah, that happened. But yeah, assuming you don't clear your cookies, you can open up multiple tabs, stay logged in all of them, close all of them, open them again. We know this works, right? We use the web quite a bit. So that's awesome. And then we don't have to worry about this either, right? Because we're not modifying the URL. So it seems like most of our problems are solved, right? But the main one around security is probably the biggest one. Still not actually solved. So this is another thing that people conflate with cookies, is they think it solves problem number one here. It doesn't. Because all it's taken is that u equals kv and put it into a thing that's still modifiable by the dev tools in Chrome or by curl or by anything. Right? Okay, so enough talking. Hopefully this was still visual enough that you were able to understand everything we talked about, yes? If not, I apologize and you can let me know. I can always try new things. We'll do some code, if that's cool with everybody. And what we'll do is, it's 48 after, so it's a good time to take a break. And then for the latter half, we'll write two different demos, as I mentioned. The language switcher, which is not user ID related. So we'll take a step back from that, and then we'll come back to the user ID thing. So that's cool. So let's take a 10-minute and re-adjourn at 10 o'clock. I would look at versus links. You're able to send data in a form, and so there'll be data, and so yeah, just most times you get and it's just that's assuming double time. Get a chance to have them. Actually, what happened like Okay, so with everybody back, we will resume. The other class is still in their break, so I apologize because I think they'll kind of come in and that'll be a little distracting, but we'll manage, right? So I have I have two projects, and so one of them, the first one we'll go through is the language selection project. So a little bit of boilerplate code, so we don't have to write everything from scratch. It's already been set up for us. But I'm going to leave it up here quickly so that you can get acclimated to it, because believe it or not, one of the important skills that you will eventually, with practice, gain is how to read code quickly that isn't yours, that's kind of quickly thrown up on a screen. Perhaps you've gone to a meetup or a tech talk and they're throwing code up on the screen. It's an important skill, whether you're junior or not, to be able to read some of it, small lines, right? And even if you've never seen that kind of code before, to be able to kind of relate to what it's doing. Look for those patterns. In this case, this is Express with Node, so it should be easier. But you could go to a meetup that's like a language that you've never learned, and you kind of have to deduce a little bit and still read it a little bit, right? In this case, yeah, we're using Express. We're using EJS as our view engine. Right? Seems like we have a home page / forget. That's it. There's not much else there, right? Yep. Yeah, I think that's just trying to be clever, but I don't really use that feature. Yeah, it could just be hard-coded to 8000. So it's saying grab the port that's passed in as an environment variable, which we haven't talked about yet, but we will soon. Or just grab 8000 if it's not specified. Because if this is undefined or false, the value of this expression will be the latter value. So it's a good way to chain instead of putting an if-else in there. So this looks okay, simple. We feel comfortable with it, hopefully. Yeah. This part here is commented out, so we'll talk about it later. And then we've got these EJS files that I want to quickly bring up. So we've got the welcome that we render on the homepage. And again, this is not going to be a pretty site. It's really just simulating like a page, a homepage, or every page really having a nav bar where there's please select your language. And we're going to make these links work. What we're not going to do is make them go to /English or /French, which will then render the English welcome or the French welcome. We're not going to do that. What we're going to do is actually remember their preference via cookies. So that they don't, if they go back to /, which is homepage, they get to see the English welcome as opposed to please choose your language. Right? So let's quickly bring this server up. And then these links are supposed to work, and they're supposed to help you switch, and a cookie should be set to remember your language preference. Okay. So I need to start working on this, and this is the server-side code. What can we do? What should we do? The links need to work, right? They're changing the user's language preference. So that's submitting a change. One would argue that that's a form post. It's not submitting a change long-term for like to be saved in the database, but it's still a state change, and state changes should be posts. We're just gonna hack it. We're gonna just do a get, because anything you can do with a post, you can do with a get, but it's just not the right approach, okay? But we're just gonna not focus on the right approach on that front, because we just want their language preference up, and then we can eventually refactor this to a post, but we won't do that during lecture. So this is the page where they do the click, but we don't want to just go to the English page or the French page. What we do want is for them to be able to say which language that they're choosing, right? So these pages, these links won't actually render an English homepage. They'll just redirect back to the homepage after they set their preference. Does that make sense? So this is simulating a site where you choose your language once and then you can come back to it whenever and it will have that language set. Right? Unless you use a different browser or whatever, you change your device. Then it won't have the cookie, right? Cookies don't, well, I guess Chrome and stuff, they share they can now synchronize your cookies so that if I'm logged in on my desktop, I can be logged in on my phone too. But assuming you don't have that set up, right? Then you kind of lose that information. So let's just say it goes to like lang en. Because it's trying to switch the language to English. And again, that's not a page. That's just a switcher URL. So how would I implement that? Well, first, let's switch that up. Let's refresh. Since I modified EJS, I don't have to restart my Node app. Click English. What do I expect will happen when I click English? Yeah, cannot get. Exactly. I expect a 404, so I always like to start with errors and then fix those errors. So cannot get lang en, and now I'm going to implement lang en. Right, the minimum amount of code that I can to quickly get that page working, not the entire solution. Again, I'm assuming Nima's mentioned this kind of working incrementally, right? Restart my node. And now when I go back and refresh and then click English, I fixed that 404 issue, page not found. And now instead of this, I want to actually set a cookie, right? And then redirect. So how do I do that? Will I set the cookie on the request or on the response? Response, because we're saying here's a response. It's going to be a redirect, so 302. But before you redirect, please save this locally. Right. So we're going to use a function called cookie that's built into Express. Okay? Don't need any middleware or any extra npm module package to do this. So we're going to set the cookie, and we just have to pick a key and a value. So let's go with lang for language. And then the value, we're going to go with en. Man, lots of typos today. How's this look? Looks okay? And then we have to redirect. Let's go back to the slash page. Right? And now, we haven't fully implemented this because the homepage will still say, which language do you want? We haven't fixed that problem yet. Right? But we're at least, this should work, and we should have a tactic to verify that this worked. Otherwise, there's no point in writing this code if I can't verify that it worked. So how would I verify that this worked? Because it's going to take me back to the home page, which will look the same. Okay, I got redirected, but how do I know that the cookie was set? Exactly. I have to then inspect the state of my browser. And DevTools is a nice thing that Firefox and Chrome and all these modern browsers have. And we're comfortable with the Chrome one, so we'll use that to just check what the cookie status is. So let's do that. And I'll go back, refresh, click this, and I expect to be on this page. So I expect it to be very confusing that I click this and I come back here. But I'm going to open up my DevTools before I do that. And actually what I should do is open this up incognito so that it doesn't have all my other cookies. Okay, so right now, no cookies. Click English. And I'm taken back to the page. So if I look in the network tab, it'll see that I made another GET request to that page, to the home page. And I see, if I check the network tab actually, that when I did the GET to enlang, which then caused a 302 redirect, right? Not only did it come back with a redirect, but in the response, we see the set cookie, right? And so now our browser is behaving well and has stored that in here. So now when I hit refresh on this page, the cookie should always be there and is technically being transmitted. How do we know? Again, you can just check the network tab, click on the latest request, and now it's going to be part of the request because it's being sent up by the browser each time. Right. So far, so good? This makes sense. This is equivalent, by the way, that the example that I used of the YMCA, right? Except it's language, but it could be user ID, as we'll see in the next demo, right? Where you're constantly bringing, because the server doesn't remember who you are. It has your long-term information, but it doesn't know how to look it up because it doesn't know who you are. And so you're bringing that ID card with you, and that ID card is your cookie. Does it include all of your personal details? No. It just includes a unique ID, so that then they can look it up in the database. Because if you lose that card and it's got all your information, that'll be problematic, right? So let's go ahead and make the home page behave differently based on what cookie is set. So what we would do here is we would need an if statement to say, if they have a lang preference of en, please render the English page. Otherwise, decide if it's going to be French or the generic one, right? So I'm going to need an if statement here. If, and the cookie is coming up, right? It's coming up with a, so it's going to be in the request object. Now, here's the problem. Do you think Express gives me access to the cookies that come up? Or will I need this cookie parser? Cookie parser? How many people? How many people don't know? Raise your hands if you don't know, because I want to know who's actually against yay or nay. Don't know? Don't know right now. A couple, like I guess 5 people don't know, and everybody else is saying yes to cookie parser. Express is an HTTP server. Cookies are a part of HTTP. So let me ask the question again. Do you think Express will allow you to read the cookies? Yeah. It's often confused by students in just the way this stuff is taught, is we jump straight to the cookie parser, and you think, that's how I get access to cookies. But let's validate that you don't need the cookie parser. We're still going to use it. There's a convenience aspect to it. But let's see what the hell that convenience aspect is. Again, what's the value proposition that middleware gives us? So forgetting this, actually what I'll just do right now is console log the entire request object and see what the hell's in there. Because apparently cookie information should be in there. Okay? So this is me just learning through experimentation here. I'm going to refresh. expect a large object that contains. Now I'm just going to search for lang on the terminal here because I don't want to go read all of that. Lang, well, obviously that's the directory, so that's not really helping. Except language, that's a different header. That's another thing we could talk about, but not part of it. Oh, and right there. Nice. It's part of the HTTP headers, so it should be there. Like any other header, like refer, like accept, like host, like connection. All of the stuff that's sent up. In fact, we can see what's sent up, again, by looking at that request. Look at all these. Accept language, right? Host, refer. Right? We can see all the headers that were passed up. So it seems like it's in the headers object. So we could actually say request.headers. Let's console log that because it's quite a big object. And now we see that, yeah, in fact, we do have the cookie header right here. So I could say just .cookie because that's the key in there. And we can see that there is a lang equals en being passed up. Now, if there was multiple cookies, we would see an ampersand, u equals kv, for example, right? And that would be just a string, which is annoying, because then I have to run like a split to split it with the ampersand. Then I would have to go through each lang equals en and u equals kv and split on the equal sign. Like, that's annoying, right? Everybody's going to have to do that. Why don't we just make middleware that does that for us? And that's where the cookie parser comes in. So there's a common confusion about what cookie parser adds to the value prop. It is a parser. It takes a string that already exists that comes up and it parses it into an object. Okay? It's not super important for you to understand that, but it's good to kind of make sure that we understand what that is. So let's start that. And now we have it installed already, so we should be able to use it. And we've registered it as a middleware. This is saying add middleware. Okay? So this means every request that comes in, there's like another function that runs before we actually hit our functions. Okay. Middleware was covered a little bit, I think, at a high level, right? And so now, not only do we get request.headers.cookie just built in, we also get request.cookies, which was undefined before. It's being added by the middleware. So let's console log that. And we'll just label it so we can see it separately. Whoops. And we're going to refresh here, and we're going to see what comes back. We can see that the cookie is still there as a string, but we also get this nice key value pair object. So we can just say .lang on that and get the value. We don't have to do any string parsing. Okay. So now what are we going to do? We're going to say, we have this. We're going to use this. We're not going to use the old school way. Don't need to look at the string directly. We need to look at the object. So if request.cookies, and we know there's a key on it, lang, so the key can be accessed as a string. But since we already know the value of the string, we don't have to use square brackets, right? We've learned about objects last week. And we know we can use dot notation when we know the key value, the key string. If we don't know the key string, then we have to pass it in as a variable or something that's dynamic in square brackets, right? If it's en, we're going to render English, right? And even though I don't have the other one, I can just, might as well while I'm here. Kind of bad habit, but whatever. Bad practice. Also program this line of code. So we better be testing this pretty soon as well. Otherwise, we're going to go with the welcome. Right? And this doesn't have to be exactly like this. Like the website could just have all of this condition in the nav itself, right? As opposed to in the home page only. This is just doing it on the home page, but a more mature site would have it on every single page on the nav with like flags or something to at the right one selected, that kind of thing. Why is this giving me a red? Oh, I have a trailing space here. So now what do I expect to happen when I restart my app? When I restart my app, my cookie is still set. I haven't cleared my cookies. So when I go up to the home page with en, I expect this if statement to execute, yes? Successfully? So this will be true. So this will be if true. In my head, I'm seeing that. And therefore, it will go in here for this scenario, right? So I expect to see the English page now when I refresh. If I change my cookie to FR, I expect to see the French page. That's the other thing I should test. And I don't need to actually test the cookie change via clicking the French link, which doesn't work actually because we haven't programmed it to work yet. I could just change FR right here. So this was a question that came up, I think, before the break. Can I change the cookie? Yes, you can. DevTools is all cool about it. Let me hit refresh. Oh, actually, didn't actually change, which is really annoying. Let's try that again. I think there's a weird, either it's a bug or something. First of all, first bug, I hit refresh, it shows no cookies. What the hell? If I hit refresh on here, it shows the cookie. But like, that's throwing me off. So just something to keep in mind if you're doing this kind of thing. Just make sure you hit refresh so you truly trust what's in the list. Second, if you're changing the value, which now it's not even letting me do, hard refresh. Refresh. Yeah, I don't know. It used to work. It doesn't right now. Chrome tends to change a lot of things. I know that they didn't allow it and then they allowed it. And for a while I had this cookie Chrome extension that would just be like another tab here that will allow me to edit cookies. So you can install that if you like, in case this is not working for you. When I tested it before the lecture, it was working. So I don't really know what's happening there. Maybe it's something to do with incognito. I have no idea. But ultimately, I could change that to FR. Instead, though, we'll just clear the cookie. So I hope that works. Click that, delete selected, and hit refresh. And so now the cookie is not being sent up, and the site is still wondering which language I prefer. In which case, when it sends the welcome, it should send /lang/fr when I click French, right? And then I would need to implement French as well. So would I then just go ahead and implement another one of these, copy paste? Or is there a better way? That was a trick question. Is there a better way for multiple languages? Yep. What's your name again? Nick. Yep. Exactly. You've already done this. Make the EN part a parameter, right? Because maybe you want to support 50 languages. Are you going to have 50 different routes defined in your app.get? Like, that's just frustrating and annoying, right? Instead, let's just make that part of the dynamic. So now this is any string followed by lang. And we can now grab it by request.params.lang. Because this key gets set on this object by express. We know this, right? Because of the ID that we've been using for the short URL. Yeah. So now I've supported French, I believe. And so let's click French here. And we see that it redirects me to the home page, but it's also set the cookie to FR because it grabbed it directly from the URL. Which means that I can actually go to /lang/es for Espanol, and that will set it to ES, right? Which it will not recognize because I only have the if-else for English and French. Is this making sense for people? Pretty straightforward, right? So let's call this demo concluded, but I want to ask a question before we move on. Is this a good implementation? Should we be implementing language selection via cookies? Have you come across this? Where you go to a website, and when you select your language, it kind of stays throughout. And not only does it stay throughout, but it stays throughout without making changes to the URL. Because I'll tell you, there are a lot of websites that make this change to the language via the URL, like we said don't do for the user credentials, because that's a security issue. But for language, it's not, right? Yeah. That's exactly the reason why websites have moved, but there are still some. That's why I asked the question. So to answer my question, have you seen websites that tend to use cookies? Probably. E-commerce stores that are really old or something like that, right? Old blogs or something. Old news sites. But once social media happened, we started to realize that people were sharing stuff even more. Not only that, actually, there's another catch to it. But essentially, let's start with what you said, which is when I'm sharing a URL, I'm more likely sharing with an audience that is, let's say, if I'm sharing it in French, that they're going to be speaking French. So when they click on the link, their cookie may not be set to French, but you want it to default to French for them. And so rather than putting it in the cookie, put FR into the URL itself. And you've probably seen, especially content-heavy websites, that actually the URLs start with /en/blog title or article title, /fr/article title. Maybe, I haven't really tested this, but maybe we could bring up an example with, let's try New York Times. Right? See the language thing at the top? What's my URL? It's just the home page. But when I click on Espanol, /es/everything else, right? So what they're doing is, they're doing something like this. If they were using Node, but other languages have something similar for routes. /lang/article ID. And they're not using cookies for that. They're grabbing it every time from the language. And they also support /article ID for just the default English, right? Do you have to have two separate ones? It depends on the power of the framework that you're using. Some frameworks will allow something like you put it in parentheses and then put a question mark, and you can actually have conditionals in there. I'm not sure if Express does or not. You can check. I think it does. Yep. Yep. Yeah. Out of scope for this lecture, but I totally agree with what you're saying. Just to repeat, the order starts mattering. You have to think about, it's going to try and check all of these in the linear fashion that they're registered, so will that make sense? Right? This is where an example is a bit of a digression, but let's say you have like, you can get, or you can post to /tweets/ID, right? And that will allow you to update a tweet. And then, and you can also destroy a tweet, right? Well, if you put that up, anytime you, let me make sure I got that right. Oh, sorry, it would be /ID/destroy. I'm struggling with the example here. Oh yeah, so let's just do edit or update. And then oh no, sorry, it would be something like, sorry? If you have a more general post, yeah, I think that's where maybe it gets you know what, let's ignore this. I'm struggling to come up with a good example, but there's essentially order matters, and I'll come up with an example for my notes. Okay. So, but kind of a digression, yes, you can make, I think you can make these optional, but you don't really, I don't think it matters. Like, it just means one other route, right? So supporting this and supporting this, both of which could call the same callback function, right? So you can still be not that much more code. Coming back to what we were talking about, social media and sharing the URL. Right? What happens when you share something on any of the platforms to the URL? It actually expands, right? And it like extracts in Twitter or whatever will extract information, metadata, title, description of the URL and include it in the tweet itself. Well, this is where they started noticing problems because they were using cookies, all these sites, and they were like, oh, it's always going to default to whatever Twitter's default language is, because Twitter's making the request to find out what data to extract. And so I'm sharing a Spanish web page, but Twitter is requesting the details in English because it doesn't have ES and it's not rendering Spanish. And so sites started moving away from language selection that is cookie-based to URL-based. So we talked before the break about all of this, like argument for cookies to put stuff away from the URLs into cookies, but we don't say that blanket for everything. Language selection, the reason I like this demo is we implement it with cookies and we realize this is a shitty solution for the modern world, for the modern web. Right? You can make it work, but people have moved away from making it work with cookies and they've actually gone to making it work with URL, the way we talked about earlier with the username. Now we're going to implement another solution that's actually going to be using user authentication. So we'll move away from this unless people have questions. Any questions?
Sorry, can you just show that example with that URL? Just walk that through again for that New York Times. So you redirect the plugin, the value of that.
Yeah, so now whichever article I go to, the way New York Times knows that I've selected English, or sorry, Espanol, is that every URL is going to have this prefix.
Yeah.
Unless I switch my language again. So now if I share this, right, let's assume Twitter is now requesting, I share this on Twitter, Twitter is going to do its kind of curl request equivalent to that route to grab the information to populate the Twitter card so that it's included nicely in my tweet. It's going to come back in Spanish. Right? I don't know if there's any, where's the body here? Right, we see Spanish here. And so it will populate all the data with Spanish.
So in the back end, you're just putting a redirect that matches in the URL.
The redirect part isn't, yeah, it's basically saying, and it may be even setting a cookie as well, but it's essentially saying, every URL needs to now include EN. And so whether they do that with a redirect or not is not guaranteed, I guess.
Yeah.
But ultimately, the important part is that they include the 2-letter string in each URL now. And maybe they also set it in the cookie so that it's easier for them. I'm not sure. Look at all those cookies they've set though, eh? Hard to say. Oh, right there. Right? But the important thing is, cookie or not, the URL is the important thing so that it's shareable much more easily.
So in that sense, they're setting it, and then the browser's also just checking it, but for usability, you can put it in there so it's clear.
Exactly. The URL is for the sharing purposes, and then it's in the cookie in case you just come back to the site. It's going to default to Spanish. Like if I close the tab and come back, right? And I just come back to New York Times. Maybe because I'm in incognito, it's going to default to English, but otherwise, yeah. Incognito tends to wipe all your cookies after you close all your tabs, right? So, hopefully I didn't confuse people with that. Feeling okay? All right, let's actually go into the next demo. So we'll CD out of this and go into user auth. And so I'll quickly bring that up. Let's close the language selection and open up user auth. And so on this one, we have another Express server. Again, it's using kind of the same kind of boilerplate code. It's using cookie parser as well as body parser for form submission, which you're already comfortable with, I believe. We've already enabled cookie parser because we know the value proposition of that now. Don't need to talk about that. As well as body parser, which is for form submission. Same idea, but for body, request body. If we didn't have body parser, we could still get the request body. It'll be a string. That's annoying. Let's parse that to an object, right? So it's doing the exact same thing as cookie parser, except instead of the cookie string, it's converting the request body string. Using EJS. And we have some users that we're going to need to populate, because we're going to pretend to have a database similar to your URLs database or users database. And then we have a secret kind of page called treasure And then we want to have them, allow them to log in and sign up to be able to see the treasure, the secret page, right? Which isn't implemented right now. So we're just going to start up the server. Whoops, got to close this one to start that one. And let's go to the home page. So it's not pretty, but it's the same idea. And there's the login page. There's the sign up page. We're not going to implement the sign up page. We'll just implement the login page just for time's sake. And then there's the /treasure, which you can only see technically. You only should be able to see if you're logged in. This is not going to work correctly because I'm not logged in, and it's gonna just show me the treasure, which literally is treasure, right? So we need to make this so that it doesn't let me do this. It redirects me back to the login if I'm not logged in. In this case, I'm not logged in because the only cookie I have set is this language cookie, which I don't even need for this app, right? So it shouldn't let me do this. That's what we need to fix. And of course, in order to fix that, I need to be able to support login, which right now doesn't work, right? So how do I go about implementing it? And do I need to implement sign up in order to implement login? I said I won't, so how is that possible? How will I implement login without implementing sign up? How could you log in when you haven't signed up yet? Yeah, just hard code the data into the user's database. We've signed up a bunch of people by default when the app starts, right? So let's just go ahead and do that right off the bat. Just for ease of use, I'm going to use, it's a key value store. This is not a production ready database because it gets cleared every time. So it's a fake database. And what we'll do is we'll just use the username as the key. So it's very easy to look up by username. And this is the information that's like all the details about the user. In this case, we're going to be lazy and just say username and password. Almost typed in my actual password there. Very bad, very dangerous. So we'll just do 1, 2, 3 there, carefully. It's part of my password. We'll put in some more. Maybe one more, I don't need that many. Okay, that's good enough, right? For a sample. So far, so good. I've written some code, so I should test it. So that's kind of bad. I should probably console log it or just run the app to make sure I haven't broken anything. But I don't think I have. Still working. Cool. Now the login post. So when I submit, this is the get for the login page, which renders the login page, which is fine, it works. But we need to support the actual, the auth posts, right? We'll just do the post for /login. So when they click the login form, I think we should be getting a post request because we saw that it says cannot post to /login. You know, we'll just keep it simple for now. Why is it making a post, you might ask? Well, if we look at the login page itself, the login HTML, it has the form which does a post to /login. Like those are the two important things that are required on the form, which is the method or the verb and the action, which is the path. Slightly different nomenclature, but same idea. The two most important pieces of a request, as we said, right? You guys with me so far? Yeah, am I going too fast, too slow? It's okay? Who's zoning out? Not even a little bit? Liars. All of you. It's okay though. Hopefully you're getting the gist of this. Okay, so we've got the server, which should now support a post once I restart it. And if I hit refresh here, even on the login, it's going to reattempt the post. And I'm going to see the post was successful. And I am going to start to have to try and actually do the step that we wrote down in our notes, which was server validates the credentials and finds the user object. Right? We're going to have to attempt this step, step 7, after the user fills out the valid credentials and clicks submit. Right? So let's go ahead and implement that. Step by step, right? So first thing I just want to see is what does the data look like? Request.body, I believe, is how it comes up. Right? So I'm just going to console log that. and hit refresh. And I see that it does send up the two most important things that I need, because the form has those two things as input fields. Each of these inputs have a name, which is the key. And that's the key that's being set and sent up with our request. How do we see it? We can actually also validate right here with my post request. The request, it's not in the URL. It's not in the URL. It's in the body. And this is just what Chrome DevTools is showing us nicely, but really, it looks like this. Username equals nothing. Ampersand password equals nothing. And the login button's value was login. It's not that important, but all three inputs were sent up at their values and keys as a string. And I can access this as a string, but I have my body parser, which will make it nice and give me that in request.body. If I didn't have the body parser, again, I have the same problem as the cookie thing, where I would get back the string and have to split it on ampersand and split it on equals and all of that nonsense, right? So what's nice is that I have body parser and I can access request.body. So with that, I'm going to go back to my server and say, okay, I have the body, and in there I have username. So I'll say const username equals what was passed up. Const password equals request.body.password. Did I get those right? Yep. Notice I'm working very I consider myself to make a lot of mistakes, so I'm double checking everything I do as I go. This is deliberate to help instill that behavior in you. It's a bit of more practice that takes that. Hopefully you're already doing that, but we develop bad habits pretty early, right? We want to get the assignment done. We want to get our day stuff done. We don't want to fall behind. These are things that kind of are necessary evils that give us bad habits, right? Okay, so with the username and password there, I'm going to have to go ahead and try to fetch the user by that username to make sure they exist. So there's the users object that I have available up here. Right. So I'm going to say users and try to access by username, so square brackets. Because if I do dot username, I'm saying get me the key with the value, get me the key username, which doesn't exist. There's two usernames and there's two keys in there, KV and MB. I want access by those keys. So I'm going to use a string, square brackets. So we're going to try and fetch the user. Whoops. And then let's just leave it there in console log user, just to make sure that that's working. And we'll just send back yo, because we don't know what to send back right now. Refresh. And we see that user is undefined. It didn't grab the user. Why is that? Because the username itself is an empty string, as we saw earlier from being submitted. So I need to actually go back to my form and put in a valid or maybe an invalid username to begin with, and expect to find undefined again, because that username is not found in the object. But if I switch it to KV, I expect to find that particular user object from the collection. Agreed? And now that I have the user object, can I log them in? No, not yet, because I have to check their password. Right? If password matches, now that I've got the whole object, which has the password in there, I'm going to compare it with the user.password. But before I do that, I have to make sure the user is even there, right? So first of all, if user, then I'm going to compare the password. If no user, we've already got a problem, right? Couldn't find by username, right? In which case we should just send back, or maybe we just redirect back to the login page. Or you know what, instead of redirecting, why don't we just render the login page? Right? Show the form again. Send the form back down. We don't have to redirect every time on a post. We can still send back HTML. And then in this case, If the password, which is called pass, matches the password, then this is success, right? But if it doesn't matches, then password doesn't match. Agreed? And so in the case of success, we can redirect, we can set a cookie for the u equals kv part. So we'll say response.cookie to set a cookie, just like we did with lang, but we'll set a cookie called use u or whatever we want, user ID, username maybe, and we'll set that to be the value, which will be the user.username, right? Want to make sure that we save that kv in a cookie, and then we redirect to treasure, which is their profile page or whatever. So far so good. And then these same thing, render login here if it doesn't work. A lot of code that I just wrote, so I didn't work as incrementally as I'd like. What's this here? Why is this complaining? Oh, shut up. Just going to leave that up, and before we test it out, feel free to read it and tell me if you have any questions or concerns about what we wrote. Scroll up a little bit. Any questions about this? Any like anything you don't understand? Oh, we'll actually get to that. So great question. The question is why use render here versus redirect? Both will work, right? Redirect sends back a 302 saying please go back to the login page. It will. Render will just save that round trip and put the login page right in front of them. And there's another benefit, but we'll talk about that a little bit after. Not as important to this lecture, but whatever. Any other questions? Okay. So let's test this out. If I go to /login and I put in an invalid username, I expect to see the login page. If I put in a valid username, but an invalid password, I expect to see the login page. It's super annoying that I have it. Like, this would be a really shitty login page in that it clears out. I guess it makes sense to clear out the password. Most sites do that. But why is it clearing out my username? That kind of is annoying user experience. But functionally, it still works, as we think. We haven't tested out the right path, which is if I put in KV and 123, and I hit login, it should take me to the treasure page. But also, it should set the username to be the username that the object has, which seems to work. Now, our treasure page isn't checking for that, but at least it seems to be setting the cookie correctly before it gets there, and it's redirecting there. So those steps, the login post is working correctly. Now we have to implement the treasure page to check for that cookie. Agreed? Oh, and it would be nice if at the bottom of the treasure page we say logged in as, because it's kind of simulating the profile page, right? So it should show who I'm logged in as. So let's program that in as well when we implement the treasure page. Okay, so we're good with login. Login makes sense. It works. There's a usability issue on it, but everything else is fine, right? And so we're going to look at the treasure now, which is right here. And instead of just blindly registering the treasure, we have to have an if statement in here too. Do they have access? So I need to check if they have access. You know, maybe I'll call it current user equals, and I have to find the user. And I know I should have a cookie, but I don't. It's not guaranteed, right? So I can do something like const username equals request.cookies dot username, just like we did with language or lang, right? Let's just console log it because I don't trust myself. I think that's right. Well, let's confirm. Refresh. And yeah, indeed, I do have the string KV being sent up on that cookie. And that's the right way to access it. But that's not the username itself is not validating that they're logged in, is it? We have to make sure. I mean, you could be, if username, we're good. They can see the treasure. If the cookie is not set, take them to the login page. This is a implementation that will seem to work. We're not checking what the username is. If any string is set on the cookie user, we are good. We're able to see the treasure page. There's a security issue here, as we'll see, but let's go ahead and try it. Restart. Go back here. Now there is a cookie set. So I expect to go into this branch of code, which will render the treasure. If I'm using double quotes, I should be consistent, shouldn't I? Otherwise, if I clear the cookie, I should expect to be redirected to login. So I'm going to hit refresh, and because the cookie is there, I'm seeing the treasure. Right? But if I clear the cookie, and I hit refresh, it redirects me out. The problem, though, is any cookie is valid. So I could just go ahead and set cookies in here, or using a Chrome extension. Or if I use curl, for example, I don't even have to guess a valid username. What was it, -C for cookie jar? Do you remember? -C. So what's an example of that? So lazy sometimes, -C and then string and then the URL. That's not what I expected. I guess you have to use --cookie. So --cookie, passing in the string, whatever string, I'm seeing the treasure page come back. If I don't include it, if I include some other key, which is not username, it's going to redirect me to login, right? And so this is not secure enough because I literally don't have to have a valid username. So we're going to have to check if the username is valid. So const user equals user's username to grab the user based on the username to make sure it's a valid username still. And if I still find the user, then I feel like I'm comfortable that they've got the right key set in their cookie. So now, with this, and restarting our Node app, if I curl with username invalid, no good. Username NB, all good. Allowed to see the treasure. And then hopefully we'll populate this as well. Right? How do we populate this? You've already done this with TinyApp a little bit. What do I need to do? This is rendered in the EJS. Yeah, pass it in, right? So I can just hard code it, just to prove the point, and say I need to pass in an object with a key, which will be called, let's say, first name. And it'll be like this. I know you guys use template vars, which I find students get confused. Like, there's this thing called template vars. No, we just call the variable template vars. And to illustrate that point, I'm hard coding a first name in there, which means that on the treasure EJS, I can now say first name. Right? Now, I will tell you this will work. Whoops. Let's restart that. This will work. So let's log in. Oh, let's not even have to log in. Let's just try the curl command. Right? Now we should be grabbing that from the object. So really it should be username is user.firstname. Right? And we'll have to, of course, specify that. Yeah, should. And so now when I curl with NB, it says NEMA, and when I curl with KV at the cookie set, I see so it's dynamic, right? It's simulating that nav behavior. So this was our demo. Logged in. I mean, I can do this with the form as well. We're pretty much done our demo in that sense. The invalid password won't work. What was it? 456 will work, and I'm logged in. And now if I can open up the tab and go back, and it will keep me logged in because the cookie is being sent up every time. So let's go back to our agenda for a second and see what we did. We did this and learned that cookies are great, but we should also include the language in the URL because sharing, right? And then for the user auth demo, we implemented login. All right, is that a good kind of takeaway? Now, what we didn't do with the user authentication demo is we didn't write very good code. For example, we might have multiple pages that need to achieve the user's logged in. We're going to have this, what was in the treasure page, kind of need to be duplicated in every route that needs to check if the user's logged in. It'd be better to just make that a helper function or a middleware or something so we could extract that. Not part of this lecture. Not going to do that here. So that's something that's out of scope, but keep in mind that the lecture notes, the code, is not something that would be considered production ready or would pass a code review by myself even, right? Let's move on from this because I do want to talk a little bit about security in the last 5 minutes that we have left. Or maybe longer if people are feeling the energies there. So did we, first of all, we never marked this, but did we solve this problem? Why didn't we solve it? We said not solved, question mark, with cookies. Because you can. Anytime you saw me do it with curl, I can literally try, put it in a loop, and just curl a bunch of times and see what response I get back. Is that what you were going to say? Yeah. Do we understand that? So cookies do not add any security. It's a common confusion. What you'll be doing today with your Tiny app, for example, is I think you start off with this particular way of setting cookies for the username, and then you'll actually make it production ready or battle ready, right? So what do you think we will have to do in order to make this, solve this problem? So that's a good point by Steve, which is maybe we not only set the username in the cookie, but we also set the password in the cookie. Is that what you were saying? When you say it that way, it doesn't sound so good. What's wrong with that? Therefore, it will be accessible. So now I have to guess two things. Username is much easier to guess. Password is much harder. So that's good. It's adding that. Brute force is harder. But if I just have access to your laptop and I quickly open up your DevTools on Facebook, and let's say Facebook was using that strategy, not only can I see your username ID or user ID, whatever they have, that unique identifier. It doesn't have to be your username. It could be some internal ID. But also your password, which is not so cool. Right? Yeah. Can you hash the cookie value? So we haven't talked about hashing at all. So see, you seem to know a little bit about it. But I'm going to talk a little bit about hashing as well. So the question is, can you hash the value? Yeah, so let me just speak to what, I'm going to pretend you didn't say hashing, because I want to speak to hashing for another point. And I'm going to pretend what you described it as was encryption. Is that a fair statement? Hashing and encryption are two separate things. I'm guessing most of you don't know what hashing is. Is that a fair statement? But I'm guessing some of you know what encryption is at a high level. Like you encrypt things so that they're not readable. And they're not modifiable either. Like you can't just take the garbage that is set in some random strings that look like they're garbage and modify them to do a guess anymore. Like if it, instead of saying username equals KV, it actually said, let's talk about this here. So issue, still easy to guess username. Solution, encrypt the session data. So instead of just encrypting just the username, what you'll use is a package called, what is the package that you use? It's called cookie session or session cookie, something like that in your assignment for today. It's really confusingly named because it's called session cookie. And so that implies that session cookies are all encrypted, which is not the case. It's just that this particular package by default will encrypt all cookies, all session cookies. Okay, so you'll have a specific module that you use for setting cookies that are encrypted. And so instead of saying username and theme equals dark in the cookie, let's say if that was, I'm just adding that as an example, it will look like this. In the DevTools, it will say session, right? Maybe not all of those random strings, but it will look like nonsense. And it will be decryptable on the server side. Really, because what it contains internally is, when you unencrypt it, it will say username equals KV and theme equals dark. Right, so that library itself uses an encryption library as a dependency. You don't have to worry about the encryption algorithm. You have to just give it a key, like how should I encrypt it, and then it will do that behind the scenes. So when you inspect the DevTools while using this package, it'll be harder for you to debug because you'll see this and you won't be able to quickly switch between KV and someone else, right? You'll be able to switch between yourself and some other user because it's hard to guess now. So we solved that problem. Any other security concerns? There's other security concerns that we haven't tackled yet. I want to see if you can guess or identify them. I'll bring up the code so you're not imagining the code in your head. Carly, you want to take a stab at this one? You haven't volunteered yourself, so I'm volunteering you. The first name being set here? Yeah. There's a more sensitive thing being set in there on the server side. Password. So is that an issue? Is that a concern? My password is stored on the server. What can happen? The server could become compromised, in which case the hackers would have the passwords quite easily because they're stored in clear text, plain text. Security issue. If you know someone's username, can you change the password? You'd have to log in as them, assuming the website is properly built. And so to log in as them, you'd have to somehow set an encrypted cookie, which is much harder. Yep.
Can you intercept post command so that if you don't have access to the server, you have access to the middle, since you're posting text.
Yeah. Yeah, so there's a separate one that I was going to get to after this, which is issue 3, which is man in the middle, or person in the middle to be more Politically correct on that? To be more inclusive? So yeah, there's a personal in the middle attack vector that we have to also talk about, but we're not there yet. That's a separate issue. Issue 2 is passwords stored on server in clear text. What's the actual problem with this? Hackers can get access easily if they hack into the server, but there's even a simpler problem, which is that the engineers have access to all the passwords. The devs or the ops people, the infrastructure people, have access to the passwords, and either intentionally or unintentionally accidentally leak that information internally or externally. Right? Should they be able to have access to my Gmail password, which is quite sensitive? Like with my Gmail password, you can get access to a whole bunch of other things, right? Because you have access to my email, you can start resetting passwords, right? And so, do they store it in clear text? No, what they do is they hash the password on the server. They cannot encrypt it, because once you encrypt it, you can decrypt it. And so the problem is still the same, right? If I have encrypted passwords on the server, but I also have the decryption key in the code, then really it's no better than clear text. Maybe slightly better. Maybe I can put the key in a slightly different server, which is not likely, but still some engineers will have access to both the data and the key, and will be able to unencrypt that. In which case they have access to the passwords still. So the solution to this is hashing, which is one-way encryption, meaning that you cannot decrypt it once you convert it, you have lost the data. There is no coming back from it. Which seems like, why would you ever encrypt something to never get it back? Well, this is the perfect use case for it. Another one is, you might have heard of hashing in the blockchain space. That's where it's used as well. Or fingerprinting different documents to make sure they're authentic. We won't get into all of those things because A, we're over time, and B, it's out of scope for the lecture. But what I will say is, today, not only will you implement encrypted cookies, but you'll actually use bcrypt to hash the password so that it can be just a piece of garbage text in the user database as opposed to an encrypted value in the database. Which means that as a developer, you can't get it back. Which seems like broken, because how are you going to authenticate them? Any guesses? How are you going to authenticate someone when the password field is showing garbage that you cannot reverse engineer to 123? I want people to think about it first. I know we're out of time, but it's a pretty cool thing to think about. You in the back, what's your name? Brian? So you've got text that is not their password. They're putting in 123 in the form. And when they signed up, you took that 123 and you converted it to XYZ. Now they're logging in and they're putting in 123. You can't turn that XYZ back into 123. But what can you do? You can take that 123. Is that what you're going to say? Is that what you were going to say? You can take the 123 and run it through the same algorithm and turn it into XYZ, the garbage, and then compare just the garbage values. And if they're equal, that means 99.99999% chance that it is the same password, if not 100% chance, depending on the algorithm.
And that algorithm would therefore be randomized on the ones you can never. Is that like the basic encryption? Is it basically you can't hack it because it assigns that key with however that algorithm spits it out? What would be like the layman's term?
Yeah, let me, we're at 6 minutes after. Can I do another 2 minutes to show you the encryption, the bcrypt thing? Or should we adjourn? You're okay?
Yeah.
Okay, let me see if I can do that quickly. Even just in like the REPL here in Node. So I can require bcrypt, right? And now bcrypt is actually a library that I've got npm installed already. So it's in my package JSON, I believe. Yep, it's right there. See that? And now I can take, let's say my password is, what was it, 123? I can just run it through the bcrypt engine, the algorithm, to say hash. And hash is a pretty expensive compute thing. So there's a asynchronous version of it because you don't want to block Node. But we'll just use the synchronous version, which is not ideal. And we'll pass in the password, and we'll pass in a difficulty number. that number basically it's more expensive and harder to crack, essentially, right? And what we will get back is the garbage. So let's just call that the hashed garbage, right? And hashed garbage now is this. This is what we're saving in the database. Okay, we're not, and this is not, you can't reverse engineer this. Okay, so this is the code you'll write. Maybe you won't use the sync version. I can't remember. You should ideally not be, but maybe just because you're building a tiny app, it doesn't matter. You're going to use this one. I don't remember. But either way, it will result in the same output. Yeah. I don't know what the range is, but the higher the number, the longer it'll take. Oops. Here we go. See how long it's taking there? It's running it like over and over or something like that. I'm not really sure how the algorithm works. Bcrypt is a public algorithm, right? Like if you have access to it, anybody has access to it. So there's actually two components. There's actually a salt, which I won't get. You can write it down. You can write down two keywords, salts and rainbow tables. But we won't get into them. This is getting into like advanced security. Could be it's a course or at least a lecture on its own. Yep. No, because there's the salt that powers the actual algorithm. So there's another string that we pass in, which is the salt, but we don't have to pass it in. So it's optional. Again, these are things that I can't answer right now. And I'm not even equipped to answer them from a cryptography perspective, right? Just from a API perspective, I can talk to them. But anyway, companies, it's very poor to use your own algorithm. It's considered like bad practice because you don't have the cryptographic kind of experience. Very few people do to be able to make something that's not breakable. And also doesn't have collisions, because what if 1, 2, 3 and 3, 4, 5 both hash to the same value? Then accidentally somebody could match a password. And so you want to be able to have uniqueness. You know, I can take a very long string and convert it to a short string like this that's unique. Wait a minute, I can take an essay and convert it to this, and somehow all essays will be unique, but I'm compressing it down to, not compressing it, but like bringing it down to this. Surely some essays will have the same value. Right, and we want to have like very small chance of that. I don't know what the percentage is, but it's like infinitesimally small. And the algorithm's beauty is that it has that ability. There's a lot of math that went behind that, a lot of PhD stuff, right? And so nobody really tries to create their own. If they do, they definitely are less secure. Your instinct is like, oh yeah, like if it's not known, then it's harder to crack, right? But not necessarily. And then if I put in the new password, so this is my login attempt, is 1, 2, 3, right? Then what I would do is, you would argue, okay, well, let's run that same password, because it's 1, 2, 3 again. I expect the same string back, right? And I should be able to compare them with the same difficulty number. As it turns out, it will be a completely different string. You'll be like, what the hell? How are you supposed to compare those? See, you notice that it's a completely different string? Right? Like clearly the last letter even is different. The first little bit is the same. Up to this $sign. Then it starts changing up on you right here. So bcrypt gives you another function, which is compare. And then you're going to use that to compare the hashed garbage with 1, 2, 3. Or maybe it's 1, 2, 3 with hashed garbage. They match. 1, 2, 3, 4 with the hash garbage. I'm using a high difficulty, so it takes a little bit. Don't match. 1, 2, 3 with the space after, different string. Not going to match. False. All right? But I cannot just compare the output of the. I'm literally running them the same string through the same algorithm, and it's still giving me different strings. This is some crazy shit happening. But it gives me a compare function to be able to compare the raw value to the garbage value that I've saved in my database. So you'll be doing this today. I know it's probably throwing you off a little bit in terms of how does that just work. I could get into it, but I realize I'm over time. So not super important, and you can read up on it. Do you have a different question?
Yeah, just real quick one. The first two already. When you did B compare sync hash garbage and B compare sync 1, 2, 3, you just changed the order.
Yeah, it's just that it needs the provided password first, and then it needs the garbage second. The hashed. I just did it in the wrong order. Like if you look at the docs, they'll say provide the whatever they filled out in the login form here, and then it will do its magic with it as well as it'll compare it with this. The first one here, it should still work because they were both with 1, 2, 3. But even though they yielded different strings, this has to do with different salts. It's actually using different salts. And that's why the first one is similar, yeah. So actually, no, the first one's not. The salt is here, actually. So different salts being used. This has to get into, like, again, hacking attempts, rainbow tables, things of that nature. Any other security issues? So we've solved. Actually, there was one that we wrote down that, what's your name again? Bobby mentioned, which is, all this is great, but if somebody's submitting a login form or a sign-up form and it's over HTTP, I can see what they're submitting for their login form. Yeah, so the password is hashed, the cookie is encrypted, but if they're submitting a login with the password, I have their password and I have the username. How? Because we can just check the network traffic and see all of the traffic that's going out over HTTP, at least in this area, and you could, if you have access to maybe more switches and stuff, you could see all the data coming through. So there was a transition that I'm sure some of you remember, which was we had Hotmail and MySpace and these services that were using HTTP and not HTTPS. Google even only recently switched over to HTTPS. So we need to use HTTPS in order to fully encrypt the login pages. And so Google, Facebook, these services encrypted the login workflow, but didn't encrypt anything else. Okay? So they were still HTTP for Facebook and HTTP for Google. What's the problem there? Why did they have to? There was another security issue with that. That's my hint. Why would you need to use HTTPS all the way through for full security? Specifically, we're transmitting sensitive information when we're logged in. What's the sensitive information that we're transmitting? No, we're not storing the password in the cookie, right? Well, sorry, not login. The other pages, like when I'm going to /profile or /treasure, there's a cookie that hopefully isn't username equals KV because we've encrypted it. So we solved the issue previously. We have an encrypted cookie now. Okay, it's being sent up to /treasure over HTTP. That means when you go to the /treasure page, what's your name? Nolan, who's got a particular app running on his MacBook, can see what cookie you sent up. Now it's an encrypted cookie. So he can't see what the username inside of it is. But can he use that cookie? He can impersonate you. In fact, if he has access to your machine right now, he goes to facebook.com, opens up DevTools, copies down your encrypted cookies. If he puts those in his DevTools, will he log in as you? Yes. Right? Yeah, they're encrypted. He can't extract value out of them. But he can use that exact string, and Facebook will be like, yeah, I guess you have a valid encrypted cookie. That's your user ID. So, I mean, we're not solving the person, the physical attack, because that is another attack vector, is that he could just have and this has happened a lot with high-tech firms that have sensitive information is people walk into the office with a USB key, plug it into a computer, right? And as soon as that USB key is plugged in, it will open up Chrome, extract all the cookies, and boom, they have all of the, at least for that particular user, they have all the login, not the username and password, but at least the particular session's username and password encrypted, right? Now, we can't prevent the physical with like physical countermeasures, like having a security guard, making sure you lock your computers, things of that nature. But on the HTTP side of things, if we're just using HTTP, we have that problem exacerbated because anybody on the network can just sniff for data being sent back and forth over HTTP. It's clear text. Yes, the cookie is encrypted, but again, he can reuse that cookie and impersonate you, right? So we need to switch to HTTPS for everything. And that'll be included in my notes. I'm not going to write it down here. I'm already over time. Is that cool with everybody? Lots of security issues come up, both on the server side with the password itself being encrypted, not hashed, and then on the communication, encrypting the cookie solved the problem of guesswork and brute force, but it didn't solve the problem of some person in the middle stealing it from you. And so we encrypt the whole communication, the HTTPS communication entirely, to make it impossible to take out the cookie itself. So you have to do both things. You can't just HTTPS without encrypting the cookie, and you can't just encrypt the cookie without HTTPS. You have to do both. And of course, hash the passwords for other reasons. All three of those things together make a production-ready, secure system. And of course, then there's firewalls and stuff like that that you have to worry about. Right? So this conversation wasn't meant to be a full security conversation, but it's a good time to talk about it. And this is a course on its own. And this is just the tip of the iceberg, kind of what matters to us as app developers. Okay, I'll send out notes right after. I have my notes that I used for this lecture, so it should be pretty straightforward. Are there any questions before we adjourn? Sorry for going over time. I'm rusty with my lectures. I don't do them as much as I used to. And this one's pretty beefy. I could slim it down, but I think all of this is important. Any questions? What are we at time? 10 after? Ooh, 20 after. Jeez. Okay. Enjoy the rest of the day. Good luck implementing your user auth stuff. Cheers.